lesson we spoke about the circle basically, and inside the circle there are different words that we need to make sure that we're familiar with, and so this just gives you kind of an oversight of those words. Now, in the previous two lessons, we focused on facts or theorems that deal with the circle and the center. And so some of the theorems that we dealt with, probably the most popular one we dealt with was that the angle at the center is twice the angle at the circumference. So the red one will be twice the size of the green one. So that was an important theorem. And then we also spoke about, this was towards the end of the last lesson, that if you have a chord and then you have a line from the center of the circle to that chord, and it goes to the midpoint of the chord, what do you know about that red line? That red line from the center, if you know it goes to the midpoint of the chord. What did we spoke about this briefly at the end of the last lesson. You can put your hand up or pop it in the chat. What do we know about that red line? So that red line, it already bisects the chord, yes, but the theorem actually is that if it goes to the midpoint, it will be at what? So a line from the center to the midpoint of a chord will always be at 90 degrees or perpendicular, yes. And then the other thing that we need to bear in mind about the center of the circle was if you have a chord, and it goes perpendicular from the center, then we know that it cuts this chord into two equal pieces. So that was something we mentioned. Well, maybe we didn't even mention it. Actually, maybe I didn't mention it in the last lesson, but you'll see it come up at the beginning of today. And then what else did I talk about? Was there anything else that I talked about? Angle at the center, angle. Oh, we spoke about that if you've got a diameter, what type of angle will the diameter always make at the circumference? Who can remember? So if you've got a diameter, you've got a line that goes through the middle, what will that angle always make at the circumference? Let's go to Bouclé. Oh, did I mute you? Sorry, Bouclé.
It will make a 90 degree.
90 degrees, yes, 90 degrees. Perfect. Okay, now there are some other ones, but for now, we're just getting familiar with these shapes. So I'm focusing more on just understanding the basic shapes for now, but just to show you a little bit of the official reason. So the one theorem that we dealt with was line from center perpendicular to the chord. And then the other theorem was line from center to midpoint of the chord. So let's just see which one was which. So the green one was the line from center. It was this one over here. That was the green one. So line from center to midpoint of chord. And it allowed us to show that it was perpendicular. And then the other one would be line from center perpendicular to chord, which is that one there. Okay, let's see a question where these are used. So it says, in the diagram, O is the center of the circle. There is O. The diameter DE is perpendicular to the chord PQ. So the diameter DE is perpendicular to the chord PQ. Give me a thumbs up if you followed that so far. If all the words are sort of making sense and you're like, okay, I'm following this man on the screen. This is making sense so far. Give me a thumbs up in the chat. Give me a thumbs up in real life. Give me a thumbs, whatever thumbs you've got. I want to see them. If you followed me so far. I'm looking for thumbs. Where are my thumbs? Aha. Let the people use their thumbs. Okay, so now it says, we know that DE is 20 centimeters, and we know that CE is 2 centimeters. So let's maybe even put, so C is 2, and DE is this long diameter. It seems to be 20. Okay, so it seems to be 20. Now it says, after all that reading, calculate the length of the following using reasons. Find the value of OC. Now, where is OC in this drawing? OC is just this little bit over here. Would you agree? Now, tell me, how are we going to work out what OC is? Any ideas? So look at what we've got. We know that we have a diameter, which is 20. We know CE is 2, but how do we find the little red bit that was there? So OC is like this. There used to be a TV show called The OC, but I think most of you weren't even born yet. But any ideas? Let's just throw some ideas out there. What tips can you throw out there? Who can tell me the length of a radii? So, or a radius. You know the diameter. What is going to be the size of the radius in this question? What's going to be the size of the radius in this question? So if the diameter is 20, then I think the radius should be 20 over 2, which is 10. So if I look at this question, OE is just going to be 10. So what is OC going to be? What is OC going to be? So I know the picture is a little bit dramatic, but I think if OE is 10 and CE is 2, then OC must be 10 minus 2, which is 8 centimeters. So this bit over here, I know it looks weird, that must be 8 centimeters. Okay, so OC is 8 centimeters. Now, if I want to find out, so that's 8. It does look smaller, I know. It must have been a dodgy scale question there. Okay, we're almost done with this one. If I say to you, what is the size? Oh, why did we minus 2? Because at the very beginning, the question said that CE was 2. So it said that CE was 2 centimeters. And then what we did, let me actually get rid of all of this. So we know that DE is 20. So the bit in yellow is 10. Okay, that's OE. So OE is 10. Now, it then tells us that CE, the bit in blue, is 2. Now, it doesn't seem like it's a very good scale drawing, but if that's 2 and the whole thing is 10, then OC would need to be 8. Does that help, Naledi? Okay, now, I want to know, using the theorem that I mentioned earlier on, what do you think the length... Ooh, okay, this is going to be a bit tricky. I want to find the length over here of this one, but I don't have any connection to that right now. But do I know what this length over here is? my red dotted bit. What is that red dotted bit there? So I haven't got PC, the pink one yet, but I want to try and get it. But before I get it, does anybody know what the red dotted thing is? Callan has smashed it. Callan, why is OP equal to 10? Why is OP equal to 10? How did you know that? I think, yes. It's radii. Okay, now, we know this is 10. We know that even though this looks dodgy, OC is 8. How are we going to find the pink length using stuff that we've learned about in geometry before? Who has some ideas? What can you do? What type of triangle is this? What type of triangle is this? It's a Pythagorean triangle, yes. So I want you guys to use your knowledge of Pythagoras to help me find what PC is. So I'll give you some time, and then when you've worked it out, tell me in the chat. So using some of you know the Pythagorean theorem off by heart, but 10 squared equals 8 squared plus PC squared by Pythag. And then if I move these all across, I get that PC is 6 centimeters. Give me a thumbs up or a like 8 out of 10 or like a 9 out of 9. Give me a, if you understood that, give me a like a 9 or an 8 or 10. If you didn't understand it, give me like a 3 or 2 or 1, just so I know kind of how people are feeling out there. Be honest so I know what speed to go at. Okay, now, if I wanted to know the length of this whole thing, so can you see I've got PC, but imagine I want PQ. PQ is a chord. What is the length of the chord PQ going to be? Now remember, you've worked out that the pink bit is 6. You've worked out that the pink bit is 6. Is there a theorem that deals with a line coming from the center perpendicular to a chord? The theorem says that if a line comes from the center perpendicular to the chord, those two parts are going to be equal. So what is the length of PQ going to be? So remember, for PQ, I'm going all the way from here across to there. And I think since that is 6, this will also have to be 6, which means that PQ will be 12 centimeters. And the reason would just be line from center perpendicular to chord. So because there was a line from the center perpendicular to the chord, it cuts it in half. And since I knew that was 6, this also had to be 6. So PQ is going to be 12 centimeters. All right. Now, this was just an example of the final type of question that relates to like the center of the circle, but I'm going to move on. The main topic for today is something called cyclic quads. If you found this little bit at the beginning tough, then don't forget to rewatch this as soon as the recording comes out. But it was just a little example of the theorems that work. So let us go to the following drawings. What I want to define for you is what a cyclic quad is. Today is going to be all about cyclic quads. So this is a cyclic quad. Well, it says cyclic quad, yes. This one is a cyclic quad. This one is not a cyclic quad. This one is not a cyclic quad. What do all the cyclic quads have in common? So as we are going to start talking about this new type of word, what do you notice about cyclic quads? This will be easier if you just put your hand up and you give me an audio snippet. How would you define a cyclic quad by looking at this picture? How would you define this, a cyclic quad? Gundo, what do you think? Callan, I think most of them are inside the circle and do not overlap outside of it. Okay, that is one way of doing it, yes. So I definitely notice the Q is outside in this one, and in this one, the one vertex is inside. So let's go to Boucle. Boucle, how would you describe this? How would you describe a cyclic quad?
So the opposite angles of the quad need to be equal to each other.
Okay, that is for proving something is a cyclic quad, but the pure definition, what if I look at these red dots, what do you notice about the red dots for the two yellow ones versus the red dots for the green and the pink one? The red dots are vertices. What do you notice about the yellow ones? Oh, I thought I saw Cullen's hand there. Was your hand up there, Cullen? So what you see is that a cyclic quad has its vertices on the circumference of a circle. So you can say for a cyclic quad, all vertices, or you could say corners, are on the circumference. So that's the reason that this is not cyclic, is that point is not on the circumference of the circle. And in this quadrilateral PSTQ, this is not on the circumference. So only these two are cyclic quads. Okay, so let us go, before I even get to this theorem, let's go to the other one. Let's go to this one. Okay, so this is a cyclic quad. And I want to see if you notice something about this cyclic quad. So the 4 points are on the vertices. What do you notice about the cyclic quad here? And it's sort of like there's pairs of angles, the red pair and the green pair. Are opposite angles equal in a cyclic quad? If I move this around, what are we seeing? So I can definitely see the red pair is 92 plus 88 at the moment, and the green pair is 87 and 93. But let's see if I move them around, what happens now? Okay, now the green pair is 120 and 60, and the red pair is 92 and 88. So what do we notice about oh, sorry, I missed the Aisha, I'll go back in a second, I promise. So what I notice is that the opposite angles in the cyclic quad always add up to 180. And so opposite angles of a cyclic quad is another fact or theorem that you need to know. And so we're going to use that in exercises that follow. But I'm just going to quickly go up because I think Aisha said that she wanted to. Oh, actually, I'll have to come back a little bit later, Aisha, because I've gone a little bit too far. So before we have our break, I want us to answer question 1, and I want you to tell me what B is going to be and what A is going to be. So what B is going to be and what A is going to be in question 1. I want you to go ahead and work that out, and then let me know in the chat what you get. Nice, Sylvester. I agree. So there's two ways you could think about this. You could either say that, or you could say A is 180 minus 86. I think I like the 180 minus because it seems a bit quicker. So A will be 94. What is my B going to be? Well, I think that B, because these two together must be 180, I can just go 180 minus 105. And that means that I'm going to get B is 75 degrees. Now, what is the reason going to be that I use to support my fact? It's just going to be angles or angles in opposite angle. What's it going to be? Angles in cyclic quad. Yes. It's just going to be opposite angles in cyclic quad. Let me just write that down properly. Opposite angles cyclic quad. I'll show you the proper reason when I scroll down a bit later after the break. Okay, let's try and work out what C is and what D is for number 2. So can you work out what C is and what D is for number 2 for today? Take a moment, work it out. It's a little bit different to question 1. What adjustments do you need to make? Is that a question, Bouchle, or is that just your hand up? You can unmute yourself if it's a question.
So in this one, we have an exterior angle.
Yeah. So I was thinking, because we haven't learned about this theorem, couldn't we maybe work out what this is? What theorem would you use to work out that one? So I think the easier one to work out first would be D, and D would be 180 minus 96. And so that should be 84. Now, what Bouchle was asking about, there is a theorem that deals with the exterior angle, but we haven't got to that yet. So I was thinking, what is the red dot going to be? Aren't angles in a straight line, don't they always add up to 180? So this would be 79. Yes, Callan, I agree. And if this is 79, well, then I know this and this one must add up to 180. So angle C is going to be 180 minus 79, which is going to be 101. Okay. For now, I'm leaving the reasons out because I just want us to focus on the pictures. We'll worry about reasons later on. So let us do see if I've got another one before we go to break time. That was that one. Let's see. Exterior angle. That's that one. Okay, let's see if you can do number 3. Then we'll take a break. Now, number 3, it really would be quite helpful. No, actually, you know what? Let's take a break. I will come back to this after break. I think we need a break for now. So I want everyone to turn their cameras on, and I want you to join me in a little bit of exercise. so that your brain can download all the information you have been learning about. So, I think we're going to start with some nice deep breaths. Or actually, no, let's just swing our shoulders a bit to loosen up. So we're going to loosen up, swing those arms so they're nice and loose. And then let's roll the shoulders back to loosen up. Okay, now let's do some deep breaths. Breathe in. Breathe in. One more deep breath. Okay, then let's shake out our arms. So just get nice and loose, floppy and loose and relaxed. Shake out this arm. Shake out this leg. Shake out the other leg. And then let's put our arms out like this and just gently rotate. And as you relax, you'll notice that you are going further. Okay. Then let's do a tricep stretch. Like this. And just hold through it. Oh, that felt good. And stretch to the other side. There we go. Yeah, then shake out the arms one more time. Shake out the legs one more time. And then let's do some heart rate raising stuff. We'll do jumping jacks and we'll just do 15. And we start in 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so our exercise break for today is done. Let's go to a little brain break question. So the game is Maths 24. Can you make 24 using four of the numbers, well, all four numbers on a card? Can you figure out how to make 24? So there's a 3, 3, 6, and a 5, or a 9, 5, 8, and a 4. Who can make 24 using those numbers? So Aisha, 6 times 5 minus 3 times 3, you have indeed solved it. So that is your card. You have the victory. Can anybody do the blue one? Well done, Aisha. Okay. I'll give you a moment. Okay, so let us have a look. Okay, unless anybody can get the blue one, I'm gonna go back to the work for today. So before we start, I just want to get a feel for your concentration. If 10 is perfect, 0 is nothing, 5 is somewhere in the middle, how is your concentration at this stage? How are you feeling about your concentration going into the second half of this lesson? Just want to get a feel for the group's concentration. Okay, so don't be afraid to stand up if you're feeling a bit tired after the day. it is important that we manage our concentration. And one of the ways we can do that is through just, moving around. That can be helpful. And since you're not in a physical classroom, you have some freedom in that sense. Let me know in the chat, how's your concentration, everyone? So Gundo, Buchle, Callan, Huena, Manila, how are we all feeling in terms of concentration? Tender, Sylvester, Sam, Tundwile? Okay. Cool. Okay, let's give it quality. We'll give it 15 more minutes and then we'll call it a day for today. So the next fact for today is what's called the exterior angle of a cyclic quad. Now, what you'll notice here is look at how I moved this thing around. The exterior angle of a cyclic quad will always match the interior opposite. So it's the green one over here. So even if I move this around, the angle will change, but the two green ones always stay the same. And this theorem is called the exterior angle of a cyclic quad. And so the exterior angle will always be equal to the interior opposite angle of a cyclic quad. So let's have a look at a question where this theorem might come in handy. So what do you think the size of angle X is going to be using that new theorem that I just showed you? What do you think the size of X is going to be using this new theorem I've just shown you? Pop your number answer in the chat. Is that an exterior angle? It looks to me like it's the exterior angle of the cyclic quad A, B, C, D. So this is the exterior angle and this is the interior opposite. X must be 100 degrees. And the reason would just be exterior angle. Let me write this out properly now that I have some space. Exterior angle cyclic quad. It's literally that simple. What a lovely question. Okay, so now if you know this is 100, what is the size of angle Z going to be? Pop your answer in the chat. Well, it's not going to be equal to 100. It's going to be equal to 80. And the reason is going to be opposite angles cyclic quad. Now, we know that the opposite angles of a cyclic quad are not equal, but they are supplementary, or they add up to 180. Okay, now, what about y? Y is hanging out over here. It's got a friend down here. What is the size of angle y going to be? Well, because that is the sign for 90 degrees, y over here must be 90 degrees because these are opposite angles in a cyclic quad. So we just write opposite angles cyclic quad. And that's it. Y would be 90. As easy as that. So in some ways, cyclic quads that deal with exterior angle and opposite angles, actually the questions are really pretty good. So I'll take a moment, take a screenshot if you want, but then we're going to go and do some slightly more detailed questions. Okay, so let's go back to question 3, which I went away from because of not being able to show you that theorem yet. Find me the value of angle X and find me the value of angle Y in this question. What is that going to be? So I think that this x has a friend over here, which is 92. And I think this y has a friend over here. So this is the exterior angle of the cyclic quad is going to be this thing. So that's the cyclic quad. And the yellow one is the exterior angle that goes with the interior opposite x. The y, so there's more than one exterior angle. And so this will go with this. So we should get y is 116 and x will be 90. X will be 92. So x will be 92. And so the reason would just be exterior angle cyclic quad. Okay. So let us go to another one. Well, actually, let me take a moment, take a screenshot if you need, and then I'm going to move on to another one. Okay, so things are getting a bit more exciting now. We are going to do question number 5, and I'm going to give you some more solo time to do this. So to answer question number 5, you have to find the value of this angle hiding all the way down here. And all you are given is this exterior angle over here. And you're also given these two little whisker things, whatever they mean. I want you guys to try and find the value of h for me. Try and find the value of h, and then let me know in the chat if you've spotted anything or you've got any tips that you think might help us. What tips do you think might be helpful? Okay, so I want to suggest that angle A is the first thing I want to find, which is down here. What is the size of angle A? So I think angle A would be 106 because of exterior angle cyclic quad. But that doesn't, just because this is 106, I need some more insight. Who can help me bridge from 106 to the H? Maybe give you another hint here. AD and AB are equal. Yes, 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 yes. So Calendar suggested, and so has Tramulo, that these ones are equal, which means the angles opposite them must be equal. So essentially, we know this is an H as well. And so what we can say is that 2H, so the two H's are 180 minus 106 because of angles opposite equal sides. And then if we then go from there and we say, look, 106 is 74, so we've got 2H is 74, which means H must be 37 degrees. So H must be 37 degrees. Okay. Let's just do a quick little check. 10 out of 10 if you followed that, 0 out of 10 if you had no idea, 5 if you were in the middle. Let me know how question 5 went, and then I know what my next one can be like. And be honest, there's no, because I'm going to choose the next question based on the numbers I see. Okay. All right. So let's go and have a look at a question with a little bit less detail, but a bit more interesting. Let's have a look. Not that one. Let's go. Okay. Let's go to this one over here. Let's try and do this one. It's a little bit less overwhelming. And I want to start by finding the value of angle X. What do you think angle X is going to be? I want everyone to put that in the chat. Thank you for everyone that voted or let me know in the chat. It helped me understand where everyone was at. So, what is the relationship? Is this even a cyclic quad? Even though it looks like a squeezed cyclic quad, but the vertices S, P, Q, R are all on the circumference, which makes me think this 120 has a friend over here. And so that's the exterior angle. This is the interior opposite. This should be 120 degrees. And the reason would be exterior angle cyclic quad. Okay, so the good news is we know what X is. Now, let's go and look at Y. What is the size of angle Y going to be? And we must take this into account. Callan Y is at 90. I agree. So Callan has seen with a flash of insight that Y is 90. What would the reason be? What are you using to help you? It's the diameter, yes. So we covered this in, I think, the first lesson in the series. But if you have a diameter, it will always make an angle of 90 at the circumference. And the reason is angle in semicircle. Angle in a semicircle. So that's 90. All right. What have we got left to do? So we know that's 90. That's 120. Now we have to find the Z. Any ideas for the Z? I don't know if I can go straight there. I might have to get something on the way. I might have to pick up something on the way. Who can help me? It feels like if I could just get another angle in the triangle, say, for example, this one here, I could piggyback off the black dot to help me get the blue dot. So what is the name of the black dot? I guess I could call it QPO. So QPO is equal to 60 degrees. And the reason it's 60 is angles on a straight line. So we know angles on a straight line add up to 180. So what is my Z going to be? What is my Z going to be? Okay, so it's just going to be 180 minus 60 minus 90, which is 30. And that would be, what would the reason be? It'd be the sum of angles in a triangle. And so this would indeed be 30. Okay. So give me a score on that one. How did that feel out of 10? How did you feel about that question? Give me a number out of 10 in the... all right. Let's find, I think we'll do, this is almost the last one for today. Find me the value of X and find me the value of Y. Find me the value of x and find me the value of y. Now notice DEFG is a cyclic quad. So what is the relationship between x and this one? And what is the relationship between this and this? X is 88 degrees, and that would be exterior angle cyclic quad. Ooh. And then what would y be? Y would be 105 for the same reason. So it would be 105, and the reason would be exterior angle cyclic quad. Okay, I suppose that was a little bit easy. So isn't x the converse? Callum, we're not talking about converses today, so we will talk about them in a future lesson, but the converse is how we show something is a cyclic quad. So in this scenario, we know it's a cyclic quad because visually we can see that the 4 vertices are on the circumference of the circle. So there's no debate. We know it's a cyclic quad. When you use the converse theorems, you prove a quadrilateral is cyclic. And so we'll have to do a future lesson on that, but that's a different type of thing. Okay. Okay, let's not do that one. Let's have a look. I think we've run out of questions for today, have we? Maybe not. Okay, I think maybe we actually can call it a day for today. So everyone, let's just do a little bit of review to end today. What are the main ideas that we dealt with? So we dealt with the idea that something is a cyclic quad if the vertices are all on the circumference of a circle. We dealt with the fact that opposite angles in a cyclic quad add up to 180. We also dealt with the fact that exterior angle of a cyclic quad is equal to the interior opposite. So basically that this angle over here will be equal to that one. Now, in the next lesson, what I'm going to do is I haven't looked at a cyclic quad that looks like this. And this is going to look a little bit different. What if my cyclic quad looked like that, almost like a butterfly? Now, is that still a cyclic quad? Yes, it is. But it's a special type of cyclic quad. And often it's called the butterfly or angles in the same segment theorem. And so in the next lesson, we are going to investigate the relationships in a cyclic quad like this. And so that is where we'll go in the next lesson.